Encouragingly, there's the beginning of a consensus among politicians, economists, and commentators that high value-added goods and services are central to recovery and to building a prosperous UK economy. And I think that view is supported by the more rapid recovery of countries like Germany, France, Korea, or Singapore, who've actively encouraged that balance. And I think that shift in opinion is positive, but we clearly have an awfully long way to go to translate intent into reality. So I'm not really making a new argument tonight, but what I'd like to do is take it a stage further and perhaps look a bit more at what it takes to succeed. In doing that, I'll talk about three central questions. Firstly, what is high-value activity? Secondly, why does it matter? And finally, what should we be doing to encourage it? So what is high-value activity? Well, I think it involves what I call deep knowledge. It has a high research and technology content. It requires profound understanding of your customer. It exploits both scientific and experiential intellectual property. It involves the definition of solutions that meet complex requirements. It requires well-developed systems integration skills. It involves managing data to inform responses to complex events. And it's difficult to do well. And I'll try and bring it alive today by looking at a Rolls Royce product, but what I'm saying could apply equally to pharmaceuticals, electronic systems, nuclear, or many other industries. So I'm trying to use this as a generic example. So I'm going to take, as my example, the Trent 1000 engine, which we designed for the new Boeing 787. There are extraordinary demands placed on an engine. The engine has to power an airliner that weighs around 242 tons. It has to take it for distances of 9,500 miles. It flies at 37,000 feet and at a cruise speed of about 600 miles an hour. It's got to start and operate at temperatures ranging from minus 60 degrees to plus 40 degrees centigrade. Because a bird strike is one of the risks that you face when you're flying, it has to be able to withstand hitting a 5-pound goose and continue to provide thrust. To deal with that, we've created an engine with a fan diameter of about 10 feet, which means that at its tip, the blade is moving faster than the speed of sound. The engine draws about 1.25 tons of air a second through it, which is the equivalent of emptying a squash court of air in less than a second. That air, as it passes through the engine, is compressed to a 50th of its original volume, and by the time the air comes out of the nozzle at the back, it's traveling at about 900 miles an hour. And of course, the final product has to operate with complete predictability and safety. And every engine requires new technologies, which is why we register around 350 patents a year, some for technology in the engine and some for the manufacturing processes involved in making it. And the task of bringing together the 18,000 or so components to create a complete engine involves managing the capabilities of your internal and external supply chain and developing the systems to support that activity. And for me, that systems integration capability is one of the defining characteristics of high-value manufacturing. And if you look in more detail at any one of the complex components, you'll find the same story repeated. They demand a wide range of skills, complex relationships, and a constant focus on reliability and sophisticated systems integration. So I'm going to illustrate it by just taking one small component, which is here, which is the single crystal turbine blade, and it's one of 66 in a Trent engine. It's grown in a vacuum furnace from a single crystal of a proprietary Rolls Royce alloy. It operates in the high-pressure turbine, which is just behind the combustor, where the gas temperatures are about 1,600 degrees centigrade, which is about 200 degrees above its melting point. it delivers the same horsepower as a Formula One motor car. And because of the extraordinary precision required to ensure maximum efficiency and safety, the blade's dimensions cannot be out by more than 10 microns. That's 10 times less than the width of a human hair. And yet, for all its complexity, it goes for about 7 million miles between services. So a component of this complexity demands the close involvement of an enormous number of parties outside Rolls-Royce, in this case 37 universities and research institutes around the world, 35 large companies, and 34 small or medium-sized companies, and a staggering range of skills from aerothermal engineers through to manufacturing technologists. And unsurprisingly, it's not cheap. This will cost about $10,000, the equivalent of over $1,000 an ounce. So this single crystal blade is a physical product, but the same principles apply to software. This thing here is Engine Electronic Controller, or EEC. It doesn't look terribly glamorous, but inside it houses a highly complex set of software, which is in effect the engine's brain, the conductor of the orchestra, the thing that makes sure that all the 18,000 components operate in the right way and integrate properly. This one is for a new engine we're doing for the Gulfstream G650 business jet. It automatically controls the engine's operating parameters to deliver maximum efficiency. Within 1/40th of a second, it detects changes in the operating environment, such as rain or a demand from the cockpit for more thrust. And within just 1 second, it automatically modifies the engine's behavior in response to those signals. The environment in which the engines operate, as I've said earlier, is one of the harshest known to electronic manufacturers. So unlike the electronics in a laptop or even medical devices, the EEC has to work at temperatures ranging from 60 degrees below freezing to the boiling point of water. It has to be able to withstand lightning, cosmic radiation, and fire. And it has a service life of about 30 years, compared to the 3 to 5 years of your laptop. So separate from the EEC, but dependent on it, is another extraordinary piece of software, the Engine Health Monitoring Unit. This collects detailed data about the performance of the engine in flight and transmits that data to one of our operations centers. And we can use that information to communicate with and respond to our customers in real time. And that's a good example of how high-value manufacturing supports the most advanced services, which only the manufacturer of the product can supply. And as with the turbine blade, the range of skills required to develop these systems is immense. So having looked at the whole engine and at two different components, I hope that I've begun to at least bring to life what high-value activity is. It's knowledge-intensive, it's rich in intellectual property, it requires high-level systems integration skills, demands and supports a highly skilled workforce and an extensive supply chain, has a close involvement with universities, high barriers to entry, and creates significant converted value. It's a slightly self-congratulatory statistic, but pound for pound, an aircraft engine is worth 6 times more than silver, whereas pound for pound, a motor car is worth the same as a hamburger. But this perhaps gives a sense of the wealth-creating capability of high-technology manufacturing. So if that's what it is, let's look at why it should matter to the UK. And I think the first and most crucial point is that high-value activities create wealth. It's no coincidence that the top 3 national economies in this year's Global Competitiveness Index, Switzerland, the USA, and Singapore, share many of the same characteristics. High levels of R&D investment, strong collaboration between industry and academia, the successful translation of research into marketable products and services, and flexible labor markets. And advanced manufacturing can clearly produce wealth at a national level, but as I explained in the Imperial lecture, it's also particularly good at extending that wealth to all parts of the country. Indeed, far more so than is the case with financial services, the benefits of which tend to be limited to London and the Southeast. I mentioned the car and the hamburger. Let me bring it to life by explaining the impact another way. If you look at Derby, which is our single biggest centre in the UK, Rolls-Royce pay is 43% above the East Midlands median. In the skilled works category, we pay 18% more than Toyota, and in Sunderland, another of our locations, 12% more than Nissan. And we can do that because of the added value that's inherent in our product. And this wealth-creating role is all the more important given the public sector's increasing dominance of our economy. The number of public sector jobs has grown by around 16% over the last 10 years, compared with a growth of just 4% in the number of private sector jobs. This is during the longest period of sustained economic growth in our memory. And of course, the public sector with its commercial salaries and defined benefit pensions is increasingly a serious competitor to the private sector, with around 50% of all newly qualified graduates now going into the public sector. Another benefit of Britain investing in high-value activities is that they open up new choices for individuals, companies, and the country as a whole. When any country seeks to develop its capability in advanced sectors, whether that's aerospace, pharmaceuticals, medical diagnostics, nuclear power, or information technologies, the implications of failure are immense. So you hone your technologies, your skills, and processes to the highest level, often operating at the very limits of what is possible. And the capabilities you acquire are all transferable to other areas and therefore open up new opportunities for all those involved. Let me just illustrate what I mean in a Rolls-Royce context. Over the last 50 years, we've worked providing the nuclear steam raising plant for the submarines, the nuclear submarines in the UK fleet. As a consequence, we have capabilities and supply chains that are established and coupled with safety-critical aerospace experience that's allowing us to contemplate entering an entirely new business sector, which is opened up by the nuclear renaissance and the fact that we're going to provide an increasing proportion of our energy with new nuclear power stations. And the very wide range of skills which civil nuclear demands will in turn open up new opportunities for the company and for those who work in this field in other high-value sectors. And they're not just restricted to manufacturing. The ability of manufacturing sector to create new service activities is also well documented. In our case, over 50% of our revenues come from high-value services based on our customer and product knowledge. And I think it's worth saying that at the country level, the Singapore EDB, who are at the core of the industrial strategy of Singapore, reckon that for every dollar worth of manufacturing activity, 90 cents of related service revenue is created. So as well as creating choices, high-value activities are defensive. They create significant barriers to entry and can therefore enable this country to respond more effectively to increasingly intense global competition. Take China and India. Both countries have, of course, already developed strong manufacturing sectors, with China's exports of manufactured goods now amounting to about $1.2 trillion every year, and India's is about $100 billion. Most people characterize that manufacturing as low-value assembly. But in fact, China and India are already moving rapidly up the value chain. China has been deliberately targeting future growth sectors. Only last month it announced 20 new industry funds seeded by government money but financed by private cash and bank loans to move investment away from the old industries into new sectors such as the environment, software, and information technology. And as China and India develop in this way, they'll create companies, as Japan did in the post-war period, of higher infrastructure investment that are effective global competitors. If you think about China with its 1.3 billion population, 118 cities, over 1 million people, a vast home market, huge infrastructure investments, you begin to realize that China is Japan on steroids. It's worth, just as an anecdote, over the next 4 days, China will consume as much steel as the UK will produce in a year. So there's a staggering market force that is driving the creation of new industries in China. And these changes are going to have a profound implication for the UK's competitive position and what we can afford to pay ourselves. According to the National Science Foundation, the average salary of an engineering graduate in the UK is $45,000, compared to $16,000 in India and $14,000 in China. At Rolls Royce, we typically pay our engineers in India a salary of about $25,000, compared with an average salary for our engineers in the UK of $66,000. So it's not surprising that as India moves up the value chain, there's a strong incentive on UK companies to locate more engineering work in India. And it seems clear that Britain and the Western economies will only be able to sustain their historically high salaries and expensive public services if we concentrate on the most advanced and technologically demanding activities, where both value added and barriers to entry are high. And finally, in this part, these high-value activities allow us to be relevant. Given the scale of the markets represented by countries like India and China and Brazil, and their very own significant capabilities, we must surely ask ourselves what we can do to make ourselves more relevant to these economies. In the past, when countries such as these wanted to improve their infrastructure, where did they go? They came to Britain. They did so because our companies and our capabilities were relevant to their needs. But now they talk to Bombardier, Siemens, or Alstom about high-speed railways, Alstom, Siemens, and GE about power generation, Arriva, GE, or Westinghouse about nuclear power, Boeing or Airbus about aircraft, Dubai Ports, Hutchison Whampoa, AP Moller Maersk, or PSA Singapore about ports. Britain now is too rarely at the top of their list. So finally, I want to turn to the most difficult of my three questions. What should we be doing to encourage high-value manufacturing? I should start by saying that I'm optimistic. I think we start with a number of significant advantages. We've got a long history of scientific and manufacturing excellence. Our manufacturing output remains the 6th largest in the world. We're capable of operating at technological levels that most emerging economies cannot currently achieve. 4 of our universities are, for the 3rd year running, in the top 10 world university rankings. And we recognize that retaining the status quo is not an option. But we do have to change to exploit these advantages. So what I thought I would do, given that there's a discussion period, is throw out a dozen ideas or so that perhaps would form a basis for the conversation later. First, we've got to reframe the debate and change our attitude and language. I think we've got to stop hiding behind the myth that Britain is a post-industrial economy, as if that was somehow a meaningful and praiseworthy ambition. Undoubtedly, the economic crisis has accelerated that debate. Politicians and commentators are now positively embracing the notion that manufacturing should be an essential part of a balanced economy. But frustratingly, the wrong language is still being used. For instance, drawing a false distinction between the creative industries and manufacturing. I would challenge anyone to walk into a room full of design engineers and say they're not in a creative industry. We must recapture the sense of excitement about science and technology that's existed in the past. There has to be a reason for young people to choose the sciences. And the inventors of the 18th and 19th century, people like James Watt or Humphrey Davy, really did capture the imagination of the public, and the sense of excitement that their inventions generated was palpable, and Jenny Uglow vividly captured that in her book, The Lunar Men. And Martin Rees, who's president of the Royal Society, made a compelling case in the recent Times article for encouraging both the sense of excitement and a more general understanding of science across the entire population. Said what he argued was that the applications and priorities of science should not be decided by scientists alone. There are political, economic, and ethical dimensions. All citizens need to address questions such as, is the world really getting warmer, and why? Should we bring nuclear power stations or windmills? Will there be designer babies? Will computers take over our thinking? And Martin points out that science is at the heart of all the biggest issues and advances of the 20th and 21st centuries. And if that's not an exciting message to convey, then I don't know what is. But they also need to believe they can make a career out of the opportunity. And I've said it before, that I remember an article by the Mayor of London, Boris Johnson, in the Telegraph, where he was bemoaning the fact that we didn't have any nuclear scientists. And I read it and I wrote to him, and to paraphrase, I said, look, dear Boris, it's really simple. If you're smart enough to be a nuclear physicist, you're smart enough to realize that you don't have a nuclear industry. And And the point is, it's changed. The fact that we now are contemplating a nuclear future is already changing the choices that people are making at university. It's instant. We should seek to create an educational and training system which equips the country with skills it will need. If you examine where we locate our new investments, we're increasingly attracted to countries with high educational standards and, importantly, strong vocational training, such as the USA, Germany, Scandinavia, and Singapore. In Britain, I think it's necessary to revisit past decisions and recreate technology colleges or their equivalent to improve vocational learning, and their curricula must be defined by industry's need and provide the sort of well-educated workforce that can support the high-value activities of the future. In the context of the current debate about university fees, we should certainly consider a system of differential fees that encourages the study of engineering and the sciences. And we should build on the success of the advanced manufacturing research centers, which are giving companies of all sizes access to state-of-the-art manufacturing technology. I think we should be shocked by the speed with which our competitors are moving up the value chain, the point I made about India and China. India and China already have world-class companies operating at the highest level of technology and at the top of the value chain. They have space programs, defense programs, energy programs, and infrastructure programs that will continue to pull through innovation, technology, and capability. And they have the market size to support the global companies of the future. In this context, we must use statistics that enlighten us rather than those which show us in a good light. We've got to be ruthlessly honest about our performance as a country and not choose comparators that flatter us or give us a false sense of security. Instead, we need to compare ourselves with the best in class and then identify the steps necessary to close the gap. Today, George Walden in the Times quoted from Arthur Koestler, who said, "Britons tend to think that reality is an irritating word invented by foreigners." And we've got more to do to secure and retain high-value investment. Most of our large, high-value-adding companies don't have to be here. Bear in mind that for most of them, this country generally accounts for 10% or less of their global revenues. They have no market size incentive to remain here. Companies therefore need other reasons to locate in the UK, whether it's the strength of our science base, the quality of our people, our approach to innovation, or government support. Next, I think we have to accept that markets are not perfect. Therefore, governments have an obligation to make choices. Whether we like it or not, other countries recognize that governments have a direct role to play in shaping and developing economic activity. John Kay put it very well, I think. He said, taken as a whole, market economies have proved far more effective than planned economies. But this does not imply that every individual market outcome is superior to every individual planned outcome. And I think Peter Mandelson was quite right when he recently said that there should be less financial engineering and more proper engineering. Perhaps there should be less emphasis on social engineering and more on wealth creation. We should promote wealth creation by pulling all the levers available to government. For example, the health budget can be used to develop world-class pharmaceutical companies. The National Health Service is the third biggest employer in the world. Let's use it. The defense budget can sustain a successful defense industry. Energy policy can encourage investments in technologies where the UK is competitively advantaged, so that we have some prospect of affording the increased energy costs associated with the low-carbon agenda. Slightly controversially, perhaps, we must get a better return from our £3.7 billion investment in the science budget. The science budget is now funded from borrowed money, and it's reasonable to expect it to do more to promote entrepreneurship and innovation, and less to support the writing of papers. The strength of our science base is a national asset, which must play a more central role in developing the right people with the right vocational qualifications and in bringing forward technologies which can be commercially exploited. A really good example of what can be achieved is the Massachusetts Institute of Technology and the halo of businesses that surround it. A recent analysis of MIT's alumni by the Kaufman Foundation showed that they had founded around 26,000 companies, employed 3.3 million people, and turned over about $2 trillion. That's the equivalent to the GDP of the world's 11th largest economy. And interestingly, they actively incentivize and help the faculty to create businesses. They have a process of educating the academic staff and encouraging them and mentoring them to be involved in business. We must change the way government operates so it has the right people to support the process of wealth creation. That means making the civil service more accountable for wealth creation and more commercial in outlook. And yes, it is vitally important for the next generation of MPs to have some direct and relevant commercial experience. And more generally, I think we must enhance the business credentials of government by having an effective appointment system that ensures there's a regular and properly used influx of experience from business, as is the norm in most competing countries. I think we've got to look afresh at how we can professionalize the management of our cities and transform them into globally competitive hubs for the promotion of wealth creation. In the future, I believe we'll see the emergence of a global network of successful world cities. Britain has more than one city that should aim to be in that league. And Singapore is an example of what can be achieved. It's a city with literally no natural resources. It imports the sand to extend its curtilage so it can build more buildings. I think you can get eggs that are created there, but that's it. You have to import the food. But it succeeded in creating a highly attractive business environment and a significant financial surplus. And it's no secret that China, with at least 15 cities with over 1 million people, sends its mayors to Singapore to train them to run a city-state. This isn't an amateur sport, and we too could learn from them. Finally, we need to develop a much clearer and better articulated sense of direction and a better understanding of what we're seeking to achieve with our economy. Business and government can then prioritize their investments more effectively and work together to address both opportunities and the areas where the UK is weak. And I'll just give an example of what I mean. I think in Britain we're all agreed that our response to the issues of energy security and energy efficiency will profoundly influence the country's economic, industrial, and social future. So what do? We debate endlessly the new regulatory regimes that have to be introduced, the different ways that consumers will have to modify our behavior, the scale, speed, and causality of climate change itself, but much less how precisely we'll take advantage of the benefits that are expected to flow from the necessary industrial scale response to these challenges. What do we really mean when we claim that Britain will become a leader in wind power? Do we mean that we'll be the biggest manufacturer of wind turbines or the biggest importer or subsidizer? The right question surely is what policy decisions will positively encourage technologies and capabilities which Britain can reasonably expect to sell to the global market? And how can government and industry work together to ensure that early and successful investments are made in what are often high risk and uncertain technologies? And what are the skills we agree we should be developing in our schools, technology colleges, and universities if we're to respond to these industrial opportunities? In short, what we need urgently is a well-coordinated energy, industrial, and education policy to ensure that our new low-carbon future is a benefit to us rather than just a cost, so that we can become an exporter of solutions rather than importer of other people's ideas. So finally, and in conclusion, I hope I've been provocative enough for the later debate, but I'd like to end on an optimistic note, really the same place as I started. We start with some real assets. If we focus them effectively on exploiting these advantages, we can without doubt become a country which is recognized globally as a natural home for high-value activity. As a consequence, we'll be a preferred location for more companies that compete effectively in international markets and create wealth in the UK, and where there's a shared understanding, whether in Whitehall, our boardrooms, our schools, and our universities, of where our competitive advantage lies. Thank you all for listening, and I hope we can have a discussion debate.